Hello everyone, welcome back to Coding Intuition. Today we are going to solve some root of leaf numbers question on LeetCode. So let us quickly understand the question. In this question, we have given a tree and we need to find out the path root to leaf path and represent it as a number, and then to calculate all such numbers and add them into a sum. Let us just understand it by an example. So as in this example, we can see that we have this tree, and in this tree we can form few numbers from root to leaf. So here we can form 4040 is a number, 495 is a number, and 49 is not a number because 9 is not leaf. We can only form number up to root to leaf. So 495 is a number, so and 491 is a number, as we can see here. So we will just add all of this number 495, 491 and 40, and whatever will be the sum is our answer. So I hope that makes the question clear. So let us quickly jump to whiteboard to understand this. So let us just first understand how we can solve this using depth first search, then we'll move to breadth first search. So as we do in depth first search algorithm, we will iterate over all over our tree, and what we'll be doing is we will, as we go to our left, uh, we will just add that number into a number. So for example, first of all, if we are at root, we will say this our number is 4. If we go to this number, we will say it is 49. If we go to this, we will say it is 495. And as soon as we reach a leaf node, we will say let us just add it in our answer. So let us just iterate through an example to understand it much better. So in this example, as we can see that first of all we are at a root 4. So let us just calculate our current number. So value of the root value is 4, so current number will be 4, would be current number into 10 plus root value. So it is basically, first of all, it will be 4. So we will run our BFS now. So we will call our function again with these values. So our current number would be 4 and our answer would be 0 in this case, and we will call it to the right as well, and our answer will be 0 in this case. So as until we complete the first one, we will put the right into our stack. So we have just put it right into the stack, and now we will move to the roots left. We have moved to 9 now. So as we have moved to 9, now we will again calculate our current number. So our current number is now 4. So 4 into 10 becomes 40 plus 9 becomes 49. So now our current number is 49. So we will just call for the same now, and we have put this inside the stack, and we have moved to our left again. So here we our current number is 49, and 49 into 10 is 490 plus 5 is 495. So we will just call our DFS for this number, and we will just go in right first. So we will put whatever is inside this to stack, put it is in the stack, and now now we are at our leaf value. So whatever is inside our current number, we will add that to our answer. So we have added 495 to our answer. So first of all, we have added 495 to our answer. Now whatever is inside the stack, we will check this, and as we can see, the first of all, this will come out of the stack, and there is nothing inside the right of 5. So we will just say we will just return as there is nothing inside left of the 5. So we will delete this one, and then we will move to this one, and we will calculate for this. So we will move to the right of 9, and the right of 9 is 1. So our root value is now 1, and at this position we can see the value of our current number is 49. So we are looking for this right now. So the value of current number is 49, and we have moved it to here right now. So the value of root is 1, so our current value will become 491, and we will just call left and right for this, and there is nothing inside the left, so that will uh, just return null, and there is also nothing inside the right. That means we are at another root. So whenever we are at another leaf, so whenever we are at leaf node, we will just add that to our answer. So now we have added this to our answer. Now we will delete this from stack, and at last we will calculate this one, and we will calculate this one from the stack, and we will move to this now. So we are here now. So in this, we can see our current value is 4 whenever we call this. So our value will become 4 into 10 plus uh, 4 into 10 plus 0, which is 40. So basically we have 40 now. We will call uh, both of these for that, and as we can see, there is nothing in left and right. Both are null, so we will return null, and we will add the value 40 to our answer. So that's how we will solve our question by using that first search. So I hope that makes it very clear. We will move to code walkthrough later. Let us first understand breadth first search solution for this. Now solution is pretty much similar to breadth first search solution and intuition, but the way of writing is just different. So in breadth first solution, what we will be doing is we will in breadth first solution we just go to the adjacent node of our current node. So we will do the same. We will put adjacent node of our current node inside a queue, but in this case we will also put a number which is forming up till this node. For example, if we are at this node, we will put this node inside the queue, but we will also put 49 inside our queue. If we are at this node, we will put this node and 40 inside our queue. So that's how we will try to solve this question. So let us just iterate through an example to understand it much better. So first of all, we will put our root value inside our queue. So we have put it 4 inside our queue, and sum up till here is 4, so we have just put it 4. And now we will pop this out of the queue, so we will put it inside the current, and we have popped it out. And now we will move to its left and right. So as we can see it, on its left we have 9, so we will push that to our queue. So we will push 9 to the queue and sum up till now. So how do we calculate the in the previous in the current we have 4 and 4. So 4 into 10 plus the value of left value. So the left value is 9, so it will become 49. So we have pushed this inside our queue, and similarly we will push another value inside our queue, which is our 0 node. We have pushed 0 node, we have pushed entire node with value left and right of it, and we have pushed 0 node, and we have put 40 here. So and we have pushed this pop this out when we have started this loop. So now we have reached to this. So first of all, this we will check this now for 4 and 49. So 9 and 49. So we will move to the left and right of 9 and 49. So as we move to left and right of 9 and 49, we will first pop this out. 9 and 49 are popped out, and we will move to its left and right. So here we will put its left and right. So its left is 5, and the sum up to here will be 495. As we can see, we have 49 here. 49 into 10 plus 5, we have done that. And here we will move to its right, and we will put here 1, which is the node, and the value up till here will be 491. So we have put it 491 inside our queue, and we will check every time if it is a leaf node or not. It is not a leaf node, and we will move to next. So as we move to next, in this case we have popped out 40 and 0. So we will check first of all if this is a leaf node. Yes, this is a leaf node, so whatever is inside our second, we will add that to our answer. Okay, and we will again check if it is a leaf node, there will be nothing in the left and right. So we will move to next values, and similarly we will check if this is a leaf node, and we will pop this out first, and we will pop this then, and check this is a leaf node. Yes, this is a leaf node. We will add the value here. So 495 is added here, and similarly for the last one, 491 will be added here, as it is also a leaf node, and we will pop out them as we add them in our answer. So that's how the breadth first solution will work. I hope that makes the intuition and the algorithm very clear. So let us just jump to code walkthrough to completely understand this search solution. It is very simple. First of all, we will call the first search from here by giving it a root node, and current value would be 0, and our answer we will pass it as a reference, so all our answers get added in a similar integer. So first of all, we will check if it is null, we will return, and at every step we will just add current number like this, as we have seen on whiteboard. We will just add root value and whatever number we have formed up to now into 10 plus the root value. And if it is a leaf node, how do we check if it is a leaf node? If it's left and right are null, it is leaf node. If it is a leaf node, we will add it to our answer and iterate over all over the tree by you doing the DFS. So that is the simple DFS code. And now let us just see breadth first search code. So in the breadth first search code, we will create a queue of tree node and integer, which is a pair, and we will just put the root the root and the value at the root for first of all. And now we will run this breadth first search, and if we will check if it is a root node, we will just return current dot second, which means whatever is inside the second value we will just return up till here. So and if it is not, we will just move to left and right and check if the current dot second, we will add the left node and the current into second plus the value at the current node. This means so first of all we have added just 4, and so 4 into 10 plus 9, and the in that example that we are seeing, so we have added 49 here and the node 9. And if we move to right, and we will simply add and as we can see in this example, we will add 0 here and 40 here. So that is the breadth first search code. So I hope that makes code and the question and the intuition very clear. Thank you so much for watching. I hope it had helped you. Bye bye.